This is Mike Bailey. He works at Atkinson. He's an owner and one of the head gurus there. He's going to teach us about communication protocols and wiring.
Sweet. You guys all know all about that stuff, right? So this is just a review, right?
That's what we don't blame when we hired on.
Gotcha. All right, so how many of you guys pull wire or look at the wire? 2 or 3 of you? What other things do you guys look at?
Pictures on the wall.
Steps.
Sweet. Okay. So inside your buildings, you kind of have 3 different protocols that's communicating to all the different devices. Okay. Those that have been here the longest probably see this purple wire in the ceiling a lot. This is our Smart 2 communications wire. Does everybody know what a Smart 2 controller is? Well, it's about 12-inch green guy. Looks like a battle tank. Works really good. Never dies. It's 80s technology. It's good, fun stuff.
But it runs forever.
It lives forever. So when they built those darn things, they made them to be robust, right? You could short an output on there, and it'll just turn itself off and say, hey, you screwed up. Power it down, power it back up, and it'll come right back to life. Okay? If you do that to any lawn device or any backnet device, the magic smoke escapes. And I've never been able to squeeze the magic smoke back in. They just don't work. Okay? So
Yeah, but the salesman starts to laugh.
the salesman smiles because
Business guys are going.
we get to get you a new one, right?
We can help you out.
So in the Smart 2 world, it uses this purple wire. It's an 18 gauge wire. There is a shield on it. When I cut it, it fell off. So you've got a shield wire, and then you also have this bare naked wire that runs down through there. Anybody know what the bare naked wire is for?
Ground.
So what are we grounding?
We're given a shielded ground to keep interference from getting in, and it's called a drain.
Right. So do we land that wire?
Interference.
Do we land that wire on both ends?
Only on one end.
Only on one end, right?
It'll be the panel.
Okay. So you're trying to make it suck down any of the noise or things around the wires to help fix the communications. So we use that to drain it down. So you can connect all those together and do that kind of stuff, okay? The other wire you guys have seen is this 22 gauge non-shielded wire that's blue, skinny. This is what we call our lawn network wire. It's not green grass. Sounds like lawn, but it's just plain old lawn. Okay.
I used to work with lawn.
So this uses what's called lawn mark protocol to communicate and do its stuff, right?
There's no shield on it,
So
right?
there's no shield. You can get it with a shield. They have a different style of wire with shielding on it. But for the most part, lawn doesn't seem to need it on what it's doing with your communication.
Doesn't pick up the trash on the way out.
It's a little different on how it does its handshake. If you're looking at a lawn wire, you can't just put your voltmeter on there and see anything, right? You have to hook up an oscilloscope on there to get to see the signals going down that lawn wire. Smart 2 wire, on the other hand, you can put your meter on there and you'll see 5 volts, no volts, 5 volts, no volts, right? It's trying to do a pulse on and off kind of a thing, so you can track that down. Lawn wire communications is really pretty robust, right? Tries to handshake and do its stuff. So it's trying to get that way, okay? You're good. Then this is what we use for our backnet protocol. It looks very similar to the lawn wire, but it has a specific capacitance value in that wire to get it to handshake The capacitance is to keep it from slowing the signal down in the wire, so it doesn't get echoes and noise kind of stuff going on. It is shielded to help protect the noise. It uses what's called 485 protocol to do the handshake down there. So the two-wire communications, it's using the method of 485 communications, but it's talking a backnet protocol, if that makes any sense. So 485 communications can be used in multiple different ways. Like on a Modbus device, that's a 485 communications, but it's talking Modbus. On BACnet, it's a 485 communications, but we're doing BACnet type stuff. Okay?
I always wondered, Mike, why doesn't the different lengths of the wire change the capacitance?
If you think about, it's how they twist the wires specifically inside. So you'll notice on like Ethernet cabling, right, you got a Cat 3, a Cat 5, and Cat 6. It's all about how they twist internally in the sleeve that helps cancel things inside. So the Cat 3 wire has a specific twist. The Cat 6 wire has a specific twist, plus it has a plastic guide to keep all of the wires turning in a certain rotation and at a certain rate to help all that stuff happen. Does that make sense?
Yeah, I just don't know why a different length doesn't change the capacitance, but
I don't know all of how that's done in there, but it's related to how it's twisted
That's just
inside the wire.
magic works.
They have certain ratings on the wire. All I
Backnet
know is it's a
smell.
low capacitance wire for backnet. Okay?
Okay.
So this class is going to be totally different than the last one. Luckily you gotta watch both videos. Right? Alright. So, in the lawn world, what do you call, if let's say I've got a Jace up here, right? And I tie these controllers together like this. And then maybe I cheat and I go out like this.
Star.
So like star ring topology, right?
Yep.
Okay?
Backnet, that's no good. One word, you're okay.
Your backnet, you cannot do that. Okay? And in lawn, technically you can do this, and they call it ring topology and star topology. What's the problem with doing this with your lawn network?
With lawn,
Mhm.
I don't like it at all. I always daisy chain, it don't matter. So,
Okay? That's
that's
our
the standard.
preferred method, is we only daisy chain.
That's correct.
I was surprised that you made a connection back on that loop.
Yeah. That- It can be done, lawn can do this.
Lawn is very temperamental. There's some issues there, especially if it's not installed correctly.
So installation is an important piece, okay? What limitations do I have doing a star network?
Shorter distances,
Okay, how short?
510. $300
Maximum length of wire on a star. Okay? Usually you'll have a terminator somewhere. You guys all seen our terminators that we sell you or put on the wires? It's like a little,
It's a 3-wire.
it's a 3-wire guy. It's got little shrink wrap on it. Inside the shrink wrap, there's some resistors and capacitors and stuff to help clean up the network. But depending on which 3 wires you use, 2 of them is for a circular network. The other 2, or the common, would be for a daisy chain network, right? What does a daisy chain network look like? What's a daisy chain?
It's one continuous wire.
Continuous spouse end.
So if I take a guy and connect all these guys. Oops, can't draw a square. It's like a daisy chain, right? Does it matter where I put this guy in the network?
No, not with one.
Okay? Is there an advantage to putting it someplace in the network?
I don't know.
I think it's better to have it at one end.
What about troubleshooting?
Hard. Well, it's easier to troubleshoot because you just can't count the circuit.
Yeah. So if you can split it, and you've got the whole trunk goes down, you can separate one side and see, is it over here? Or is it over here? You've saved yourself half a day's worth of work because you now
The MTC.
pointed it to one spot, right? Lawn communications is very robust. These kids or the VAVs on that particular guy are like attention deficit children. They are screaming constantly on that wire. So if you think about your VAV card, every time the airflow moves, right, the airflow is not a steady number, right? He's bouncing all over the place. Every time that number changes in like the 10th decimal place, it wants to tell everybody on the network that he changed. Okay? So he's constantly screaming on the network trying to share his information. There's things in a lawn controller that we can tell it not to do that. We can say, you have to be quiet for 10 seconds. I don't care if you sent the message, you have to wait 10 seconds to send it again. Okay? That's to help manage the noise and communications on that network. Now again, there's nothing on a lawn network that tells a card when he can talk. So they all just try to talk at the same time. So they'll bang into each other, right? Both of them, I got new airflows, and they'll both try to say things at the same time. The packet will garble, they'll see that it got garbled, so then they'll randomize inside and say, I'm gonna fire off at this time and you'll fire off at a different time and try to miss each other. But you're working with a bunch of devices, right? How many guys can you put on a lawn wire?
32, maybe. So 32.
That would be a beautiful network. Usually I don't have stuff like that. Anywhere from 60, I've seen up to 100 on a lawn network.
Well,
I don't like them at 100, but 60 seems to work really well.
And if you daisy chain, how far can you go?
Guesses?
8,
2500.
I think it's
2,000.
2,000.
I think it's 2,000 feet. Okay? That's the recommended length, right?
Maximum.
I'm assuming, right, you've got a little lawn connection down to your T-set too, right? We count that as part of the network too, I think. But most of it's out that way, okay? The hard part with lawn for you guys and troubleshooting is in the tools, you can see that these two guys have bad packets a lot, right? That doesn't mean that their wires are bad. Sometimes the wire is bad over here. Okay? How do you, if I take that nice lawn wire, I just fold those two connectors together and slip it in and screw it down, is that a good connection?
No. It's a bad condition.
How come? I got a nice piece of metal that's pinching against two wires.
They like to be twisted.
One does not recommend installation to be twisted, no more than 3 to 4 times.
So for some reason, the dumb thing just doesn't want to handshake through that very well. It doesn't want to go through the metal. And the metal's changing some of the capacitance.
We have a lot of problems with that out here on campus in the lawn, in all of our buildings, is because the installations and poor practices due to how it was installed. We experienced that up at the MTC, Lee and I did, tracing water power. problems associated with the communication out to the newer facilities, so there is an issue with that.
So you do want to twist the wires together on the ends and put them underneath the connector and pinch down on it, okay? A couple of things are there. One is, right, oxidation on the wires can cause things to get stuff, but if you got it pinched together, it doesn't really let the air get to in between very well. So it keeps the oxidation out, seems to tie it better together, and seems to work good. So you want to make sure you twist those together before you stick them under the terminal. Just makes it work better. And I recommend that on all the protocols. Smart 2, not so much. You can slip the wires under and just crimp it down, it does its thing. You're not talking very fast on a Smart 2 card, right? Anybody know things are rated in baud rates, how fast it communicates? Lawn, it's like 76.8. VACnet, most of our stuff is 76.8 speed. Smart 2 is 1200 or 12 baud. If you count, it's 1200 baud. If you had SMBUs, which I don't think you guys do, they bumped up to 2400 baud. That's way less than 76.800 speed. You get a little more forgiveness in how it handshakes, right? So if we think about some of the different protocols that we have, right? We have lawn, we have BACnet, we have Smart 2. What other ones do we have around campus?
Modbus.
Okay. That's the majority of them, right? They have different things out there called Profibus, CBus, lots of other protocols, right? They're just different languages, usually on the same kind of wire. Okay? So if you climb up in the ceiling and you see the blue wire, the little skinny guy, you're pretty sure it's going to be lawn. If you see the orange wire, it's probably going to be BACnet. If you see the purple wire or a white wire that's at 18 gauge, that's probably going to be your Smart 2 programs. Okay? All right. Any questions on lawn? Usually the terminator's on both ends, right? We'll have a terminator over here and a terminator over there. And again, they're trying to pull the noise out of communication. I've seen a lawn trunk that didn't have a terminator that was landed this way. Two wires weren't connected. It was still communicating. But as soon as I put the terminator on there, it quit. So I was trying to go through. So lawn's really quick as a quick response type thing, right? All the kids talk when they want to, so everybody's just listening for packets or things that might be theirs to grab it and hold on to it.
So on lawn, is that what, Smart 2, obviously, but lawn is Delta?
Lawn is more of your Talon
Talon
product line that we're using in the buildings here.
Delta's back.
So Delta style is our BACnet line that we're using. Down here, Smart 2 is the old green cards. Modbus is coming out to your power meters and stuff like that. Sometimes VFDs use Modbus. Most of the new
Power meters, I think.
For the most part, it's power meters down here. So Modbus is just a different, it's still using what's called 485 communications, but it's requesting it in a different language, so to speak. So all these different things, this is a 485 protocol, this is a 485 protocol, but they talk a different language on that same wire, right? So you're talking French through the phone, you're talking Spanish through the phone, right? The guy on the other end has to know what you're asking for. But it's still using a similar handshake You both have phones on both ends, right? Okay. You think about it? Okay. So as far as your campus, this is a no. Don't do it. Okay? No stars, no ring topologies. It's all that way. Okay? Again, my suggestion to put in the Jace in the middle is to help you troubleshoot in the long run. You can split the trunk, find out which half might be giving you a hard time. And don't think the noise, if these guys are having a hard time talking, it doesn't mean that their wire's bad. It might be someplace else. That's the hard part about lawn, is it's robust. It's trying to get those messages out, but the echoes and things that might be happening in the wire might be affecting somebody else. So the worst problem about lawn is you may have to go box to box to box and just check them.
So this works better than Christmas lights, no?
A little bit, not much. Not much. Right? So trying to chase those all out. All right. So in the Delta world, you'll have a system controller. And on this controller, you'll have a Net 1 connection, you'll have an Ethernet connection, and you'll have a Net 2 connection coming off of this guy. I'll just use a different color wire. Okay? Let's keep drawing. So on the Net 2, you'll have your kids up here. These could be BAVs, right? Or some other, let's see, it wasn't in this class. This is usually called a DSC, and these are called DACs, or DVCs. Different kinds of controllers. These are kid type controllers. This is more of a parent type controller. So in the way the protocol works in BACnet, is the kids really don't talk unless they're spoken to. Okay?
I don't have any grandkids like that.
So
So is that token passing?
this communications that's happening, we're gonna get the lid off, is MSTP, the Master Slave Transfer Protocol. So let's back up just a little bit. How many of you guys know how to count binary?
Ones and zeros, that's all you gotta know.
Right, ones and zeros.
Yeah.
So on most controllers, there's a little dip switch thing on there that's labeled 1, 2, 3, 4, 5, 6, 7, 8, right? And you got these little toggle switches on there. Okay? If you look close at the board, it also has silk screen numbers on here. It says 1, 2, 4, 8, 16, 32, 64. Okay? To count binary, all we have is an on or an off switch. So to help us be able to count a number, if you add all of these up, what does that add up to?
128.
Is it 128 or 127?
127.
Yeah. Well, I'm not there.
But you count the zero, yeah, it's 120 choices.
Technically, you could do a 0, but usually not. So we have 127 possible combinations from this switch setting, okay? So if I turn on switch number 5 and switch number 1, that's generating a MAC address of what?
17.
So 17. You add the silk screen numbers together. That's going to be these guys across the bottom. All right? So if I need 23, what am I going to turn on to get 23?
16 or 1, 2, 5,
And it would be your 25,
And
so
three.
60 and 3 and 2. And
So we need to turn this one on, right?
16,
3, 2, 1.
And if I put 8 on, that makes what? 24?
24, so
So I can't turn 8 on. So then I do these 3 guys to get 23. Okay? Does that make sense? So if I did a really hard one, I told you I wanted 64, what would you turn on?
7%.
Right? Just one switch. So they're always adding together. So any switch that's turned on, you add all of these numbers together. Okay? How important is this little dip switch on each VAV?
You wanna talk to me, it's important.
So, these guys have to have a unique dip switch on all of them. You can't have any duplicates, right? So, if I set this one's to number 1, and I set this one to number 1, 2, 3, 4, is there any problem with that? So I set this dip switch to 1, and I set him to 1, 2, 3, and 4.
Because you come off of that two,
Okay?
that two is on,
But it's on, yeah.
Like
Like Jeff said, the system one is on, the DSC is on
three
that one.
networks, 3 potential networks, right, for the DSC. right?
So I have 3 possible connections to this guy. On this VAD card, right, if you look at the card itself, there's a net 1 and a net 2 on that card. Right, and I've got a net 2 and a net 1 on that parent card. So if I take this net 2, which net does he hook up to on the kid card?
2 seems reasonable.
Okay, get your little chance, right? A lot of installers do that. They'll take net 2 and take it to net 2. That doesn't work. Okay? So you'll come out of net 2 and go to net 1.
Wouldn't it
On a
just-
child
just
control.
be for the thermostat?
That two's
Some
a-
child
all
with that
devices
card.
underneath it.
Correct. On a DAC controller, this is called LinkNet protocol coming out of net 2. And this one is the MSTP. Okay? So you have to kind of get your head around it, but you're coming out of net 2, going into net 1. Net 2 to net 1. Now what if I had 2 system controllers, or 3? You got N1, E, net 1, net 2, net 2. Excuse me. How do I connect the system guys together?
All the net ones together. But would it work if you made one a child to the first DSC?
If I tried to put this guy over here, he'll keep trying to fight to get on the top because he knows he's a DSC.
That all the net ones, that's the network.
There is a cheat, right, inside this controller, there's a jumper that says sub on there. So you could tell him he is a sub controller, not being used as a system controller, and he will sit over here.
And then you just pay a lot of money for another DAC.
So do you guys know the difference between a DAC and a DSC for hardware wise?
You know, the DSC has a clock.
So every device has a clock chip in it, right? They can all track time, but only system devices hold the time. So if you kill the power, the system controller uses the battery or the supercapacitor on there to keep the clock chip going. Once he gets power, and he can broadcast that time to all his kids and get them back synced up. Okay? That's the main difference, besides a little more memory. He's got a little more memory on it.
Put a schedule in them as well.
I can put a schedule here, I can put a schedule here. They can be in any place. Just this guy, when he powers up, he knows what the correct time is when he starts. Everybody else has to wait to get it. Okay? Sorry, allergies. So one way to connect this together, as Matt said, is we could take the net ones and we could tie the net ones together, and then all of those panels will communicate to each other. Okay? Stick more devices on there, right? So remember, we're limited to 127 devices on a wire, right? But our networks are much bigger than just 127 different controllers, right? Well, how many controllers you got on campus nowadays?
Matt knows.
If almost 300 cases.
So 300 JACEs with about 60, 80 devices underneath each one. It's quite a large number, right? So using the dip switches and what we call auto addressing in the Delta world, this orange wire landed to each one, and then you set those dip switches. This guy would be what address? 2? This one? 3? This one?
It could be 1, 2, 3, 4, whatever.
Does it matter what order I do them in?
No, as long as they're unique and they're separate.
As long as you don't have two of the
You
same
want-
number.
If you want to make it simpler for the maintenance guy down the road to troubleshoot, you put them in order.
Very good. So it's nice to follow. I know I'm going address to address. It's helpful.
Then you have a remodel.
I don't always get their luxury. Somebody cuts a wire. So something will happen, right?
Yeah.
So we talked a little bit about this master-slave transfer protocol, right? So this system controller has a token. He's got a baton. He's going to give it to address 1. And he's going to say, okay, what do you need? So address 1 will ask for his stuff, and he'll pass the baton to address 2. Address 2 will do his thing, he'll pass it to 3. 3 will do his thing, he'll pass it to 4. 4 will do his thing, and he'll pass it to 5. 5 doesn't answer. What does he do with it?
Throws you back.
Sends it back home, gives it to the parent. Okay? Okay? Same kind of thing. 1 to 2 to 3 to 4 to 5. This one's doing 1. Looks for 2. There isn't a 2. So what does he do?
Look for 3 and 4 before he passes it back.
He doesn't. He looks for 2. 2's not there. He gives it back. 1 gets it. Goes to look for 3. Oh, I got 3. I'll give it to him. 3 looks for 4. Oh, there's 4. Jumps to there. 4 looks for 5. Doesn't find it. Sends it back home. 1. I don't know if he looks for 2 again. He kind of creates a table inside of kind of where things are. But I don't know for sure that he doesn't look for 2 again. Pass it back. Go to 3. Go to 4. 5 wasn't there, so go to 6. Send it back.
That's why you don't want big gaps in your numbers.
So usually I recommend 1, 2, 3, 4, all the way through, so that they're handshaking fairly quickly. It's milliseconds, right? But every second counts when you're trying to get data out of these things. Okay? How fast do these two networks communicate.
Pretty quick.
Faster than they can
76,
run.
8.
So it's 76,800 baud.
On both net one and net two, okay?
Excuse me, yes. So both net one and net two both can talk at that rate, right? What happens if I have something out here that doesn't talk that fast?
That thing has to be reduced.
The whole network goes slower.
So I can slow down the whole network to be 38.4 or 19.2. The one drawback about that is if you take a new BAV and you stick it on that network, he's gonna be 76.8. And you're gonna have to plug into him and tell him to be slower. Otherwise, he won't show up in your network, you won't be able to find him, you'll be wondering why. It's because you changed the baud rate. Okay? All right, so this is 76.8 as well, right? What's another way I could connect those controllers together? These system ones.
Do it with a switch going in.
IP device.
So then, we could hook up a switch. So it's an Ethernet device, right? And he's gonna come in and go into the Ethernet port. And you probably got a nice PC sitting somewhere that wants to be able to talk to those guys. Okay? Can I leave it wired with the wires I show on the screen?
You can if you shut down the net one inside the car.
Okay, so technically, you can't have both of these working at the same time. BACnet's not smart enough to use Google to track its way around. It only knows to go one way. You give me one path, I can take it. You give me two paths, I'm lost. Okay? So they call it a circular network. The cards just freak out, nothing talks, everything goes to the handbasket.
So Scott is.
Excuse me. Have to get me water. What's the advantages of going to Ethernet?
Faster.
So it's faster,
Communication.
so it communicates quicker. Besides getting the stuff faster, is that helpful?
Yes, more information quicker.
So we can request more data in a shorter period of time. And that's kind of helpful because we got a lot of things in the world that want to talk to these guys for some reason. Everybody wants to do analytics or look at trend logs and all this kind of stuff, right? So if we can increase the speed of how it has to handshake, then it's helpful for it. Each device has what's called a buffer inside of how many requests it can handle at one time. So it's usually like 30 requests. So if I've got a PC wanting to talk to all these VAVs, he's trying to push all that through that little guy, either on a slow wire or a faster wire. So the faster we can get through, the quicker those requests can get through and get cleared. Okay? Going Ethernet, you can add another layer, which is called IP, BACnet IP. Okay? Is there an advantage to that? So I didn't say this in the last class, but you have Ethernet
Incoming.
BACnet, and you have IP BACnet.
Somebody down there sucks.
Right
Always
at me.
rolling down.
Okay? Ethernet BACnet is what we call a broadcasting protocol. So the card doesn't know where he's sending the message to. He just yells on the wire, "Hey, this is what I have," and he waits for somebody to grab it. Okay? So if these guys are going through the switch and talking to each other, this one just broadcasts out. One of these two guys grab it and respond back to the message. They both see the messages of all the stuff going on. If we bump it up to IP, right, so that this controller has an IP address, this one has an IP address, and this one has an IP address, then he requests directly from that particular device. He doesn't have to yell out for everybody to look at it and see what's going on. So that can help speed up communications because they're forwarding the information directly to the guy that he wants, right? Ethernet connections on our Delta product, what's the standard speed of a connection that you can do with Ethernet? So you have gigabit, 100 megabit, 10 megabit.
It's
Different
limited
guys.
Based on the Ethernet connection we have.
So certain controllers, the DSCs, all they can do is 10.
10 megabits, right?
10 megabits. Okay? Most of the switches you're buying today are gigabits. Some of the cheap ones can't slow down enough to talk to my stuff. Okay? There's another controller called the EBCON. He has a 100 megabit chip in him. And it's all based on the Ethernet chip that's manufactured inside the device. And it's all about cost. They could design them with gigabit connections, but it's just more money you have to pay for them. Someday maybe they'll bump up that high. Right now they probably won't. Okay? The other thing that I didn't talk about in the last class is IP allows you to go through a switch to a router and get to another building. If you don't have IP turned on, it can't leave the building that it's in for handshaking. It's still using the same wire and all that stuff. It just can't go anywhere. Doesn't know how to get there. Okay? All right, to make this a little more complicated, each wire has a unique number assigned to it in the BACnet world. Okay? Delta tries to do it this way, if I remember correctly. I think this is 20,000 and some number, 20,000, another number, 20,000, another number. This one's 50,000 and a number. This one's, if it's IP, it's 10,000 and a number. If it's Ethernet, it's 40,000 and a number, I think, if I remember correctly. These might be flopped, but that's what I remember. So Delta tries to do what's called DNA. Delta network addressing. Tries to auto address things for you. It's a pretty handy thing that they came up with. A lot of other networks, you have to decide what all these network numbers are going to be and manage them and keep track of them, that you don't have anything mixing and going other ways. Okay? So those become like street addresses. As I mentioned before, each controller is trying to learn how to get to someplace. Okay, so if controller BAB number 4 needs the zone temperature of BAB number 4 up here, he has to know how to get there. So he has to know he has to go to here, because he's his parent, and he knows he has to go up here to this controller to find that guy. So he can only have one path. So if you've got Ethernet connected up, he's going to go Ethernet. He can't use another path. That has to be disabled. Then he'll go out and ask that guy for his request. Okay? The way Delta does it is it takes the MAC number, the dip switch setting that you set, and it adds that to the trunk. So this becomes 20,001. This one's 20,002. This one's 20,003. These get a little more tricky. If I powered up number 3 first, and he didn't see anybody, he would make this network 50,003. And then when this powered up, he'd see, oh, I got 50,003, I'll just use that. And then he'll do the same. If I powered up this one first, that would be 50,002. And then the rest of the guys would try to follow suit. Okay? That's really tough when you're using a Jace, because he doesn't know the numbers are switching around. So sometimes you have to take off. There's a little DNA jumper on here. You have to take that off and assign all these numbers by hand on the parent controllers so they don't try to change their network numbers. We still leave it on the kids, because what that does is when they're system controllers, this controller becomes 300. This one becomes 200. This one becomes 100. And the kids know their parent. So this becomes 101, 102, 201, 202, 301, 303. Okay?
But the 20,003 stays valid as well.
Yes.
The trunk name, not the child name.
Yeah. Okay. So, if you happen to have accidentally connected these two trunks on the same floor, right, it'll create what's called a circular network, right, because he thinks he can get to these guys going on his own trunk, or he has to come up through a certain network and get the other way.
That's what happened over at the JFSB.
And it freaks it all out, it doesn't know what
All
to
kinds
do.
of problems.
Right? It goes crazy. Okay?
It was connected through the basement.
Yeah. So it's an easy thing to happen sometimes. You might have a trunk wire going down through the building and somebody pull off to pick up something and went to another floor. Gets tied in by mistake. I've also seen people take net 1 and come out to the kids by mistake. And the kids keep moving around because they're not sure which controller they're really underneath when you do that. So it kind of freaks it out how it handshakes. Okay? So, how do we connect? Because you have buildings that have lawn, you have buildings that have Modbus, and you have buildings that have mechanism. How do they all communicate to each other?
Jace.
So how does the Chase do that?
Magic.
It's all magic box, right?
There's multiple language gateway.
Seer.
So,
Seer can translate.
the whole happy thing about a Jace is he was designed to be the normalizer of multiple languages, right? So he's taking the French and the Spanish and turning everything into unique blocks that are the same. So if it's an analog number, it becomes a numeric point. If it's a Boolean on and off guy, it becomes a Boolean point, kind of a thing. So the Jace has this handy little lawn card in here to talk lawn. And you might have another card in here that's talking on the Ethernet guy, right? So you got your Ethernet port up here. And you may have another 485 card that could talk directly to a net or an individual device. Again, you can't have all those working at the same time, right? You can only have one path to everything. So you have to decide which type of networks you're going to be using and how to enable and disable those in the controllers. Okay? Let's see, did I get everything on here? Mostly. I didn't talk a lot about LinkNet. Right, I put that one controller up here. You have a Net 2 on a DAC. This is a proprietary protocol that Delta uses. And usually this is a stat. Or it could be a field module, a DFM. So if I needed to add a couple more points to that controller, I could hook up a little IO module under there and have it talk LinkNet. Now the LinkNet protocol still uses the BACnet wire, like the other ones do, but it's not using MSTP, it's using LinkNet protocol to handshake to each other. So it's like using a different language, right? So we got Danish over here, we got French up here, we got whatever going out to Modbus, right? They all kind of use the same wire, right? They're still using a 485 chip to do the handshaking, but they got a different language on there. So it has to know what it's trying to talk to. Okay? I didn't talk about in the last class, but I can plug in to this VAV card and I can see the whole network. Right? I can work on this VAV by plugging into this one. If I set up the network correctly, I could go to a whole nother building and work on it by plugging into this spot if I wanted to. Usually it takes too long, so I don't like to do that very much. Right? I kind of like to keep them as separate networks. But again, if you're connecting all the buildings together, this is where you have to worry about numbering, MAC address. All those things have to be unique across the whole network of what can see each other. Okay? So everything has to be unique and done. So this number here is called the MAC address. MAC. The 300 called your instance number. Every instance number in the whole network has to be unique. So if you plug your laptop in, it has to have a unique number. The MAC numbers are duplicated all over the place just because we only have 127 of them. But with the combination of the wire number and the MAC number, you can kind of find where those things exist. And then because the instance number is completely unique everywhere, that's how it finds its way around. Okay? So what's the difference between a DAC and a DSC?
Remembers the systems.
This has some way to keep the time inside. It's got a battery, or it's got a supercapacitor on it. Okay? EBCOMs have batteries, DSCs have mostly batteries, I think. Maybe the newer ones will come out with the capacitors, I can't remember. Okay. The one thing that also gets tricky is an Ethernet protocol and an IP protocol are on the same wire of Ethernet. But you only have one enabled, even though it's a single wire. It can talk two ways. So you have to, for the guys doing the software stuff, you have to decide which one you're using to make that work. Okay? Alright. And then also on the Jace, right, you got another serial port or a 45 port that can come out and talk to Modbus. Excuse me. Or it can come out, talk to Smart 2, right? So I can have Modbus, Smart 2, BACnet, LAN, all that stuff on one of the Jaces and have it integrate all that stuff together. Okay, so a different, one other thing that Delta has, you've probably seen it, is there's a thing that's about, not quite that big, but close. It's called a hub. So this Delta hub has a unique controller. I keep thinking it's an SCR, but I'm not sure if that's right or not. I'll have to look. But it has a specific automotive protocol that it talks out on this wire. Still uses the same orange wire. And then we also have a power wire that comes out of this controller that connects to this guy. Okay? So it's a total different protocol. I can't remember if it's CAN bus or whatever, but it's an automotive protocol, how it handshakes. I can hook 8 of these little guys underneath this controller. Okay? Don't have any down here yet. So these guys could daisy chain together. Again, everything's in series. This little hub has a bunch of features in it. So you put it on the ceiling, sits like that access point for your Ethernet, right in the middle of the room. Inside it, it has an infrared temp sensor that reads down here at the desk level and calculates an average room temperature. Okay, instead of the one on the wall. So if you have a cubicle farm, right, if you kind of see the temperatures in the area. It also has a motion sensor in it, so it can see that you move.
So with that calculate, I mean, in a group like this,
Uh-huh.
it's gonna see all this body heat.
Yeah,
It's not gonna see the air temp, not,
You're gonna be looking at the surface temperature as far as what the temperature is, or gonna be looking at all?
so it has a
all of
temp
us,
sensor
Especially
in
those
it.
with bulk heads.
It has a temp sensor in the unit itself, and then it uses a smart algorithm to look at the space and see what the average temperature in the space is. So there's like a crosshatch grid kind of a thing that it looks at.
Okay.
So we're part of that grid of temperature,
Averages it all.
but it kind of makes what's called a smart temp for that whole area.
Yeah, so
Is that like an occupied and unoccupied?
So the motion switch can be for occupied, unoccupied. It has a microphone on it, so it hears noise. So if you're typing away and it went occupied, it knows to stay occupied because you're still in the room, even though you may not be moving. Okay? There's a lux level sensor on here to see how bright the room is. So you can control the lighting. It also has a temperature of light, right? Your light has different temperatures. So sunlight has a certain temperature range. LED lights have a certain temperature range.
Did Russ leave?
Fluorescent
one of those?
lights,
He brought one
He
down.
did, he brought one of those down.
I don't know if you did
Yeah,
or
it's been a
not.
while back. It was-
We did bring one to show you.
Yeah.
Yeah.
And then it can look at that. If they get smart enough, someday they might be able to make this thing be a people counter. So it could tell that you have 10 people in the room, right? Or not. It has some of those capabilities, it just hasn't been
Not
designed
only that
into
it's
it.
occupied, but what the level of occupancy.
Right, it could. It's not there yet, it's possible, stuff that they might do,
How
right?
big of a space is this designed for?
So this guy will read, like in this room, it's about 20 foot square, right? So it would read this room pretty good. Depending on the height of the ceiling, kind of changes its cone view of what it looks at. Okay?
So theater really would not work there, or an auditorium.
We'd probably have to look at that and see. It probably would read, but I'm not sure.
How far?
It's set to be like a 10 foot or 8 foot, 12 foot area ceiling, I think, right now. Is what they developed the lens to do on there.
And it's got a backlight, you can change colors.
So then the little ring you can use for communications, right, to say, hey, I saw a command or whatnot. So the whole idea is, this little controller can talk to this, You can add on a little module and you can do 0 to 10 volts out, right? You could use that to run up and down your blinds. You could put a card access module on here, it could do door locks and stuff like that as well. It has an RF transmitter in there, so a lot of the new projectors and things receive RF commands. So if you put it in a screen mode, it could possibly turn on the projector. You could turn on a DO and cause the screen to come down, make the shades go closed, change the temperature, dim the lights, you know, all that light harvesting, all that kind of stuff. It has lots of capabilities to figure out what's going on, right?
Insurance 50% occupied.
You know, some of the thermostats that we're putting in now on LinkNet, right, they have the display on there. They have a RGB color palette behind them, so you can change the colors of the stats. Right, so if BYU lost to the U, I could turn all your stats red. Right, that'd be good, right?
Blinking. Oh, yeah. Siren, random siren.
I always wanted to do a hospital and say code blue and make all the stats go blue, code red, make all the stats go red. So we all know what's going on, right? That was fun.
Turn them all red now.
Just do it.
Just get used to it.
Just get it over with.
When you
Or-
control attitudes, that'd be great, you know, just calm down all the kids and make them all go crazy with that.
Like, you know, schools, if, you know, some of the elementary schools and things have lockdown, stuff like that, right? If you could change the stat color, I could notify the teacher of what's going on, so they don't have to make announcements or, you know, scare people. You can do a lot of fun things with it, just lots of capabilities and what it is. You guys have any questions on some of this? I know we blew through a whole bunch of it. How many BACnet devices can you put on a trunk?
27.
60.
60 to 100.
Delta says 50. We've done 60. If you go more than 60, you have to put a repeater in. So the repeater,
Smart 2 is 32, right? I think there's more
I
than
think it was
32
about
devices in Smart
No,
2.
30 to 40 years.
Is that because of the distance? Because you can only go 2,000 feet?
Sometimes it's distance related, other times it's just how it's addressed. It doesn't want to do more than a certain number. In this deal, the 50-60 is really how many handshake hops that it has. The longer you get, the more you gotta wait, because right, you're passing that token to everybody. You could put a repeater. This has little dots on there that are all the addresses of 1 to 100. And then it has, I think, 3 trunks off of it, so you could do a set of BAVs, another set of BAVs, another set of BAVs. And then if they're active, the lights turn on. If a trunk gets noise or shorted down, this box will just turn off that network and let the other ones keep working. Right? And then you have to power cycle this to get this network to come back. So we don't put a lot of them in, mostly because it's more cost. But as far as troubleshooting and seeing what's going on, they are kind of nice if you can put them in. So if I had 2 addresses the same, that light would blink a certain way to say, hey, you've put 2 of the same address in there. If it goes offline or loses power, it blinks a different way.
That's assuming everything is wired correctly. There's no series in there.
And then if it's got multiple, you know, one trunk that goes down, they'll blink a different way. They have little,
It also tells you if it's healthy or not.
has a green light, a red light, or an orange light, changes color for the health, or amber, yeah, of the wire to see if it's working. If it goes red, it's turned it off. It's not gonna talk to anything on there. The only way to clear it is to power cycle this and let it find its way around again. Okay? So sometimes they're handy to have if you're troubleshooting. So sometimes I'll have one of these in my truck ready to wire, and then I'll just pull this off and plug that repeater in there so I can see all the addresses and power it up. And then when I'm done, I'll just put it back.
And so if you put that on a circular network, it would show that you got multiple at the same address?
No.
If it was a circular network, it would freak it out and shut it down. Because it's got too many things going on that's not supposed to be there. So it would mark it red. If I do have two dip switches the same, then it sees the dual response and it'll make the light blink differently. It won't tell you which ones, right? You gotta go find it. But it'll let you know. Okay? Other questions?
If you're using IPNet, you still need a BBMD for strong applications, don't you?
So what does BBMD do? I didn't talk about any of that because it's software based, but if I have a router and I make it a BBMD device, there's a reason for that. What does BBMD stand for?
It's gonna store two addresses. This address wants to know what that address is saying.
So it makes it a backnet broadcast device. So when this guy requests information from this one, he's allowed to share that to the other network. If you're trying to connect your computer into that network needs to be able to share to you. So it has to be a BBMD device to be able to broadcast that message out. Otherwise, the message just hits it and it won't broadcast internally either. It won't send the messages anywhere.
You have to have a table built for that, right?
So it's an addressing scheme thing, right? When you make it a BBMD, he knows, oh, I'm supposed to be sharing my information out and in to this area network.
You have to have a table inside the device that knows what you need to show.
Now, the BBMD table is telling you where the BBMD devices exist. And again, that's an address thing, right? Everything has to have its unique path to get somewhere. So I can't have two BBMD devices in this network because they're doing multiple things of the same thing. I only have one. And BBMDs are to allow you to communicate outside the network that you're in.
So it's gonna run off the central plant and get the weather information every time.
If the two networks are separate by IP address, they can't see each other, the BBMD would allow the two networks to merge and be able to share data from one side to the other.
So that's different from setting up your IP properly so it can go through the router?
Slightly. So if you make it a BBMD device and he's supposed to talk to like your PC someplace, right? Then he doesn't have an entry for the PC in the BBMD table. He just knows he's a broadcast device. So when the computer tries to connect to the BBMD and it handshakes, then he knows he can share that data to that device. If I do a BBMD table, that's merging two networks together. So the chiller plant network and the Kimball Tower building, if they know about each other, then those two become one single network. So then you can only have 100 device in
In the both.
the whole network. Okay? So that's where the BBMD table comes into play. So for example, the Boyer Company has 20 buildings down Salt Lake, and I made a single network to where I could connect to one BBMD and I could see all 20 buildings. But I could go to a building and plug in, and I could only see the one building at that time because it's a slower handshake. Or I could connect from home and connect to each building individually, or I could connect to a BBMD device and see the whole 20 buildings again. So the BBM table is making networks merge together. But BBMD also needs to be so you can connect to it remotely outside the network.